Hello, welcome, and thank you for zooming into the void with the Danville Science Center, presented by our and your friends at Danaki Associates. I'm Science Ben, Immersive Experiences Coordinator for the Danville Science Center, and your host for our tour of January sky. It is not just a new month, but a new year, and 2022 promises quite a few astronomical events to get excited for. We'll count those down in just a bit, but we're going to begin by discovering our day. Here we are outside of the Digital Dome Theater of the Danville Science Center. We are facing the southern sky. Taking a few steps back, we can see that to our right is the east, to our left is the west, meaning north is directly behind us. Looking at our clock in the corner, it is just 3 minutes past noon on the 11th of January, 2022. Gazing skyward, we can see that the sun continues to sit low in the sky, slowly clambering up from its lowest apparent journey across the sky at the winter solstice. That means that it will gradually start getting darker later at night as we journey towards spring. Darkness falls tonight by 6 o'clock tonight. We can see that moving through time to just after 6. Doing so will reveal the light from more than just our sun. We can actually spot low in the sky not one, but 3 planets here outside of the Danville Science Center: Mercury, Saturn, and giant Jupiter. Mercury reached greatest longest eastern, not that star, we want to look at Mercury. That was probably a satellite. Mercury, greatest eastern elongation, meaning it had its longest journey across the sky, Friday. Tonight, it is actually at its highest journey across the sky. Moving through time rather fast. Tonight it's moving on its highest journey across the sky. Keeping our eyes on these planets and moving through the month, we can see that very slowly Mercury and Saturn will move past the horizon, so that as we enter February, all we can really spot without being polluted by the light of the sun is Jupiter. So keep an eye on those planets while you can before they move past the horizon, and you'll have to wait until later in the year to spot them again. Returning to today, or rather tonight, we'll go a little bit later into our evening, let's say right around 8 o'clock. If we gaze upward, we can find a bright, large, waxing gibbous moon at 71% illumination. If you spot tonight's moon, gaze towards the east to find the familiar arrangements, the 1, 2, 3 stars of the belt and 1, 2, 3 stars of the sheath of mighty Orion, the Hunter. Orion has quite a few bright stars, as well as the constellations around Orion, creating the winter asterism of the winter hexagon. You'll be able to spot all of those in tonight's sky despite the brightness of the moon. If we gauge behind Orion, we'll go a little bit later, so it's peaking above the Science Center. Behind Orion is one of my most favoritely named constellations, Monoceros, meaning one horn or unicorn in Greek. I am able to admire Monoceros and the light. I am able to admire Monoceros and the other lights of the night sky, thanks largely to the quickly cooled mixture of fused sand, minerals, and other chemicals that results in the typically transparent material known as glass. Even if you don't wear glasses, you can still thank glass for greatly expanding the view of humanity. In 1608, Dutch eyeglass maker Hans Lippershey patented a device he called a kijker or looker. This device consisted of a concave glass eyepiece aligned with another convex lens, allowing a viewer to magnify an image up to 3 times. This device was replicated and its origin refuted, but it regardless proved so popular that it was gifted to King Henry IV of France. It was another Frenchman who reported the early telescope to Italian thinker Galileo Galilei. Beginning in 1609, Galileo built his own telescope, improving on the design such that he could magnify an object by 20 times. Changing the course of history and birthing observational astronomy as we know it today, Galileo pointed his telescope to the sky, being the first recorded person to observe the cratered surface of the moon, the rings of Saturn, sunspots, 4 of Jupiter's moon, and a diffuse light arching across the sky, later to be named the Milky Way. Galileo's telescope was instrumental in validating the heliocentric model of the solar system, that is, that the sun is at the center. For that, he was put on house arrest. Over the next few decades, improvements would be made to the lens and larger telescopes were built, leading to further discovery of moons and more detailed information on the planets. This style of telescope is known as a refracting telescope. A lens known as the objective is placed on one end of a long tube with an eyepiece placed on the other. As light enters the objective, it bends or refracts, causing parallel light waves to refer to a focal point. In 1668, Isaac Newton built upon a prevailing idea that telescopes should use mirrors rather than lenses. His reflector telescope used a large concave primary mirror as its objective to focus light onto a smaller flat diagonal mirror that projected an image into an eyepiece on the side of the telescope. This construction was simpler, easier, and cheaper. It also had a wide field of view and did not have some of the issues of viewing color the same way that refracting telescopes did. Over the next few decades, more and more telescopes would be invented, but the original design wouldn't change much. They would get larger, but otherwise these 2 early types of telescopes proved to be what stood the test of time. Larger telescopes allow for further viewing, for more magnification and thus further viewing. In 1897, the York's Observatory in Williams Bay, Wisconsin, built what at the time was the world's largest refracting telescope. It utilized 3-foot diameter doublet lenses and was housed in its own building. The large structure marked a change in thinking around the use of telescopes for exploration, from a hobby to a dedicated scientific pursuit. Famous astronomers such as Edwin Hubble, Gerald Kuiper, and Carl Sagan were all known to use this telescope. Its size and its limitations led to the realization that large telescopes need mirrors. Reflecting telescopes became dominant in larger and larger observatories. These structures were increasingly placed in remote areas to limit the effects of light pollution. They were placed at higher and higher elevations, placing them closer to the stars. Regardless, even the best telescopes were subject to distortion due to Earth's atmosphere. In 1990, NASA and the European Space Agency, ESA, cooperated to build and launch a telescope into space that would overcome the effects of Earth's atmosphere. With a nearly 8-foot objective mirror, the Hubble Space Telescope was not the first, but it was one of the largest and most flexible space telescopes ever deployed. In its more than 30 years of observation, it has captured some of the clearest images of stars and planets humanity has seen. Hubble also includes tools for viewing light outside of the visible spectrum. However, at 31 years old, even Hubble has its limitations to what it can capture. Fortunately, last month, December 25th, Christmas morning, the successor to the Hubble Space Telescope, the James Webb Space Telescope, finally launched into orbit. Fully deployed, its primary mirror spans over 21 feet, nearly 3 times as large as Hubble's. This will allow Webb or Webby to capture 7 times as much light, making fainter, more distant objects brighter. The JWST also utilizes advanced tools for viewing light in the infrared spectrum. As objects move further away in our ever-expanding universe, the light from said objects is stretched into lower frequencies. The furthest observable objects have had their light stretched below red into the infrared spectrum, making them invisible to our eyes from our location. Webb's tools allow it to see these objects, unveiling components of the invisible universe. Webb successfully completed deployment of its massive gold-plated mirror this Saturday morning, officially putting the telescope online and ready to record observations. The telescope will continue journeying over the next week to its final orbital destination of L2, still some 230,000 miles away from its current position. Webb reaching this destination is just one of a plethora of astronomical events to get excited for in 2022. Events like the James Webb Space Telescope. Not only the arrival at James Webb at L2, but the transmission of the first images from this massive and historic telescope will happen this year. Perhaps it will be a detailed image of a planetary surface. Maybe it will plunge the depths of a nearby nebula. It may even capture the decomposition of a shooting star. Speaking of, 2022 has no shortage of meteor showers, with one of its most exciting having peaked a week ago. Though the quadrantids were most active last Tuesday, producing meteors at a rate of 110 an hour, you still have one more chance to view them pre-dawn tomorrow morning before they move past the horizon. In April, the Lyrid meteor shower will put on a display, May will bring the peak of the Eta Aquarids, August will see the Perseid shower, and December will close out the year, predictably, with the spectacular Ganymede shower. It and the quadrantids being the only major meteor showers to not originate from a comet. Another exciting astronomical event that occurs with steady predictability is our moon. Chances are you've heard of a blue moon, the common name given to the second full moon occurring in the same month, despite the moon not changing color. On April 30th, we will experience a black moon, though you won't see it. A black moon is the common name given the second new moon occurring in the same month. We can't see it because at that time the illuminated side of the moon will be facing away from Earth, leaving us leering at the dark side of the moon. Black moons occur once every 32 months. Humans have been to the moon, and we're going back. Next month brings us closer with the launch of the first step in the Artemis lunar mission, Artemis 1. Artemis 1 will feature a new Orion capsule aboard NASA's new mega rocket, the SLS, or Space Launch System. This will be an uncrewed flight to test these new advancements in space exploration tech. If successful, a crewed mission, Artemis 2, to orbit the moon will follow in 2024, with Artemis 3 following that, with the promise of putting the first woman and first person of color on the lunar surface. In 2022, humans aren't just exploring our own moon, but also those of other planets. This summer, ESA will launch the Jupiter Icy Moons Explorer, or Jwst. Jwst will closely survey the larger icy moons of Jupiter, Ganymede, Callisto, and Europa to determine if these moons possess liquid water beneath their frozen exteriors, and to discover if that water can or does contain life. Jupiter will be putting on its own show this summer. In the pre-dawn sky of June 18th through the 27th, Jupiter will join Saturn, Mars, Venus, and Mercury in a line in their correct order. All 5 of these planets are bright enough to locate with your naked eye. A crescent moon the morning of the 24th will serve as an additional landmark for locating the planets, as it will be well positioned between Venus and Mars. We're also discovering more about big space rocks this year. NASA's Jet Propulsion Laboratory will launch its Psyche mission in August, destined for a unique metal-rich asteroid orbiting the sun between Mars and Jupiter. Asteroid Psyche appears to be the exposed nickel-iron core of an early planet. Exploring it could reveal more about our planet's own iron core, as well as the formation and life cycle of planets as a whole. Don't you think we forgot about Mars? September brings the launching of a joint effort between ESA and Russia, that of the Exomars Lander. This lander will join NASA's Curiosity and Perseverance in exploring the Martian landscape, but with this specific astrobiological objective of discovering past signs of life. Not to be left out, China will also be furthering its endeavors into astronomical exploration with the launch of its own space station. The Tiangong space station, translated as Palace in the Sky, will circle our planet in lower Earth orbit, the same orbit as the International Space Station. Once completed, the Tiangong will be 1/5 the mass of the ISS and about the size of the decommissioned Mir space station. Its core modular launched last year. The launching of 2 more modulars and a crewed mission are planned for later this year. I think that's all that's left is to look forward to this year, our events revolving around the sun. Though you should never look forward towards the sun. Not directly. April and October, that month. April and October will both display partial solar eclipses, when the moon blocks part of the solar disk in the sky. April's eclipse will be visible in South America and parts of Antarctica. October's partial eclipse will be visible from Europe, the Near East, and Western Asia. Meaning, here in America, we won't be able to see either of them. However, we will be able to view both partnering total lunar eclipses that occur this year. Lunar eclipses occur when the sun, earth, and moon align such that the moon crosses through Earth's shadow, darkening and reddening its color in the sky in what some refer to as a blood moon. May 15th brings the flower moon eclipse, and November 7th will bring a second chance to see the moon blush red. What astronomical events get you excited in 2022? You can send comments or questions to me, Science Ben, via the Danville Science Center's Facebook page, and we may just include your submission in our next broadcast. We thank you for joining us for today's broadcast, the first void of 2022, and we are excited for all of the astronomical discovery the year holds. We look forward to your joining us in the conversation, continuing the second Tuesday of next month, February 8th. Until then, stay safe, stay healthy, and stay curious. Bye.